Thank you everyone for making it today. Sorry about the weather, sorry about the late move. We only found out about that several hours ago ourselves. An hour. Turns out when there's a lot of rain, things break. Today we're just going to go through some revision. So in here, not currently in GO3, we have this revision lecture going on, but also over in J17. There is a live Q&A that will be happening from 1 to 3 with some of our tutors. We also have a more in-depth linked list tutorial over in J17-202. So J17, the Ainsworth building. But today, here we'll be running through revision for the whole course. And So, 30,000 feet?
From a very high level.
Right. So you have 30,000 feet. Going to go through some memory stuff for memory, pointers, arrays, functions, strings, and file I/O, and then structs. So that's all going to happen in the first part of today, which will go up until 1 p.m. Then we'll have an hour's break for lunch. From 2 till 4, we have some stuff on linked lists, stacks and queues, sorting and searching. And then we'll also be talking about preparing for exams and some debugging tools you can use when coding or in the exam. These slides are not actually up on WebCMS3 at the moment. So, I am Curtis, I am not Andrew. And this is going to be a brief introduction to C, brief revision of C syntax. So after this, you should be able to remember how to use variables, arithmetic and Boolean operators, control flow, branching, looping, using functions. Basic stuff from the first few weeks of the course. So, this is our main function. The main function isn't doing much at the moment. What I want it to do is we're going to play a bit of a guessing game. Now, for this guessing game, I'm going to need some numbers to guess. So the way I would do that is I have to store the number in a variable. I would declare that variable with something like, stop doing that, int hidden equals, now I need some sort of hidden number to guess. Let's just make it 5 for now. That's a nice, easy, hidden number to try and guess. Then I need to somehow get someone to try and guess that number. So I would have some other variable, and then I would read a value into that variable. I use printf to make a prompt, scanf to read in a number, give it the address of that variable. We say this is where the variable lives that I'm reading the guess into. And we say if guess is equal to hidden, printf, you guessed correct. Otherwise, you guessed incorrect. Sad face. Very simple guessing game. So we have some variables. We have printf, scanf. I don't have DCC here. So we are going to have to make do without, because I was not prepared. So if I run guess, enter my guess 4, you guessed incorrect. Guess 5, you guessed correct. This is a fun game, isn't it? If you guess the number 5, you win. I think we can probably make this a bit more complex. First off, let's try and split this bit into its own function. I like functions, so we're going to have a getGuess function, which takes our guess returns it. We can just say up here int guess equals get guess. It should still work. 5, you guessed correct. 4, you guessed incorrect. But let's say I want to do something similar for the hidden number. So I want a function that looks very similar, but this one actually gives us the hidden number. Enter hidden number. So I can get it to ask for the hidden number. They type in the hidden number. And just to make things extra cool, let's actually try and hide the hidden number. I've got a special thing there, which I hope works. Next thing we need to do is read in the hidden number. Guess, enter the hidden number, 24. Close the screen, now I have to guess. 5, you guessed incorrect. Now, still not all that interesting. I've got some nice branching in there. We've got ifs, we've got a condition, we've got some use of functions. But just having one guess isn't a lot of fun. So there's something else I should do. I should make this a bit more reasonable. If I just let whoever's entering numbers enter in whatever number they like, it might make this game a bit hard for whoever's having to guess. So what I'll do is I'll say if hidden is greater than or equal to hidden min, is less than hidden min, or hidden greater than or equal to hidden max, if your number must be between %d and %d. New line. This function call looks like it's getting a bit long, so I'm going to break it over a few lines so I can say hidden min, hidden max, exit 1. Just kill the program. Run it. If I enter like -40, your number must be between 0 and 1000. All right. How many guesses do you think it would take to guess a number between 0 and 1000? Who thinks they could guess any number between 0 and 1000 in 5 guesses? Who thinks they'd need 6? Who thinks they'd need 10? Who thinks they'd need 20? Nonetheless, I think 1 is a bit cruel, so I think we should probably try and have more guesses. One other thing we should do, instead of get guess, let's make this check guess. What I'll also do up here is define false as 0 and true as not false. And so check guess takes one guess and checks if it is correct. Returns true if guess was correct. So now I can say enter your guess. And I will say int correct equals guess equal to hidden. So what I can do is I can get this check that says whether or not guess is equal to hidden, and I can store that in a variable. I can return that. Something else I'm going to do here is I'm going to say if correct is less than hidden, printf your guess was too low. Can I just say else would that make sense? If I wanted to tell someone if their guess was wrong and their guess was too low or too high, would this if statement do that? Who thinks this if statement would give me the result that would make the most sense? Yeah, who thinks that they might not behave the way I want? So there's a few more hands for not. The reason why this probably won't, because if I guess correctly, this is going to tell me I guessed too high. So I'm going to change this slightly, and I'm going to say false. I'm going to assume that if you make a guess, it's going to be incorrect, and I say if correct, if guess is equal to correct, then huh? Yeah, that's true, hidden.
And likewise on line 7.
Which 7?
Correct, let's see.
Right, guess less hidden. Thank you. This is why we should prepare more. Anyway, so now it says if the guess is the same as the hidden value, we say that you were correct. If it was less than the hidden value, we say it's too low. Otherwise, you were too high. Simple guessing game. And so now I can just say check guess hidden. Compile it again, you run it again, enter a hidden number, 24, enter your guess, 12. Your guess was too low. So I said one guess might not be enough. So what I can do is I can now just stick this in a loop, right? So I can say we find out whether or not they were correct, and we can say while not correct. So I can say whilst they didn't make a correct guess, correct equals check guess hidden. How many guesses would you get with this program? How many guesses would this program give you to guess that number? As many as you need. It would only stop once you've made the correct guess. Let's try that. So if I compile that and run, and Shashank, would you like to come up and type in a hidden number for me?
I happen to know that you can guess this in 10 moves.
10 moves? Okay.
My maximum is still 1,000, yes?
Your maximum is still 1,000.
Hang on, what?
Now I have to guess? You entered a number?
Oh, yeah.
Oh, you think I can guess this in 10 moves?
Yes,
Oh,
yes,
let's try 200. Guess was too low. 800, too high. 400, too low. I think I'm getting closer. That was a bit disappointing. I think what we need here is printf. You guessed correctly. Yes?
Can I ask you, why you making your correct an integer rather than Boolean?
Because all values in C are in some way an integer. So a Boolean is really a number. And the way Booleans work in C is if that number is 0, then it is false. Otherwise, it's true. So in C, we don't there is no built-in Boolean type in C. In C, we just store a Boolean value, which could be 0 or it could be something else, inside of some sort of integer.
And that's why you can point false to it.
Correct. Because false is just a number. Does that answer your question? So, Jachet said that I would be able to guess that in less than 10 guesses. How would I enforce that? How would I say that you only get 10 guesses to guess this? I could add some sort of counter. So I can say int guesses 0. I've made no guesses. That's not true. I've made exactly 1 guess. Let's change this a bit. Let's just say false. And I've made no guesses, and I say guesses equals guesses. This one. Is there a shorter way I could write this line? I could say plus plus. Much fewer characters. And then what I can say here is I can say whilst it's not correct and the number of guesses is less than some maximum number of guesses. What was my maximum number of guesses? Oh yeah, it's 10. Some maximum number of guesses. Then it goes through the loop. So I go to guess. Let's say there's a hidden number 20 here, and I go 20 is the hidden number. I say, is it 1? No. Is it 2? No. Is it 3? No. Is it 4? No. 6, 7, 8, 9, 10, 11. Well, there's a few problems there. What happened? I got 11 guesses, and also it told me I guessed correctly. Still not doing quite what we want. How did I end up with 11 guesses? Because I can't count. That would be why. Excellent. Glad it's me and not the computer. The computer is much better at counting than I am. And what I can say here is, instead I put a condition here. I say if guess, if correct. All right. So I have 10 guesses. Can I have a volunteer, please? Anyone at all? Anyone? All I need you to do is come up and type in some number between 0 and 1,000. Sure. Not sure why that's cut off at the side. Oh. So you're going to enter the hidden number, and the rest of us are going to have to guess. All right. So some number has been entered. I didn't see what it was. None of you saw what it was. Can someone give me our first guess?
500.
500. That's an interesting choice. 500 is too low. Can someone give me our second guess? Someone said 750. This is interesting. Still too low. What was that? 1,000? Too high. You be quiet. Can I get the next guess? 900. Too low. 950. Too low. 990. Still too low. 999. Well done. We got it in less than 10 guesses. Anyway, that program worked pretty much like we expected once we got to the end. If we go back and look at the code, we see a few interesting things here. This is a bit of magic that lets me clear the screen. You don't have to understand what that's doing. It just helps add to the fun. I've defined false and true here. Hash defines, useful, they help us define constants. Technically, you can put other things in there. Please don't use them for anything other than constants, because if you use them, if you put things like variable names in the middle of your hash defines, which the compiler will let you do, it makes your code harder to debug. I have seen this, it's not fun. Constant though, fantastic. So we have false, we have true, we have some hidden min, hidden max. So if we read through these, we can probably guess that they relate to some hidden value. There's a minimum and a maximum for that. I could go and change these. I could say, make this 2,000. I could say, give you 11 guesses. I know that there's these two functions here. There's one that gets some hidden value, one that checks a guess. We have a main function. It should be pretty clear what this does. It gets a hidden value. We then make a number of guesses less than the number of whatever our maximum number of guesses is. And if we get it correct by the end, we say, you were correct. If we get it correct sooner than 10 guesses, we exit our loop early, we get it correct. If we go down and look at how getHidden works, you can see that asks for a hidden number, it has to be in between two values. If it's not, we exit the program early and give an error message. Otherwise, we return the value we were right in. And then we have this check guess function, which just reads in someone's guess, figures out whether or not they guessed correctly, and if they didn't guess correctly, tells them they were either too low or too high. And it would be easy to go in and add some extra features to this program. For example, if I wanted to tell someone they ran out of guesses, it would be easy, because I would just say, well, else, printf, you ran out of guesses. It's pretty simple. What did I say we would cover? I said we'd cover variables. There were variables in there. I said that we covered arithmetic and Boolean operators. Well, we added something together, so I guess that counts. And we had some ands and ors in there. So these Boolean operators that I'm talking about is this. There are three important ones here. We have this not, which says we take some Boolean value and take the opposite of it. So if correct is true, this is false. We have this and, which takes two Boolean expressions, and if they're both true, then the whole thing is true. We have or, which takes two Boolean expressions, and if either one of them is true, then the whole thing is true. In fact, it's a bit more complex than that, because if we take a look at this and, if this first one on the left is not true, we actually don't care about the one on the right. We never even check that one. Similarly with or, if this first one on the left is true, we don't check the one on the right. We don't care. We already know that it's going to be true. And our other operators are things like our less than, our greater than. So we have less than, takes two values if one is less than the other. Greater than or equal to. And our equal to. So those are our Boolean operators. We have variable assignment, can change the things in variables. We have branching, if conditions let us make choices. Loops let us do things multiple times. Functions help us break up code so we have very easy to understand code. Any questions about any of the stuff that was covered in that few minutes? More than a few minutes, yes?
I can't understand what is exit 1 in your code.
Is what?
Exit 1.
Exit 1. Excellent question. Where did I put it? Exit 1. So, functions normally return. But here, something happened. Here, something happened that we didn't like. We got a value that wasn't one of the ones we were looking for. Some things we could do here, we could ask for the value again, let them try again. But in this case, what we do is we spit out a message saying, you did something wrong. And instead of letting this program return, there is a special function we can call called exit. And exit just stops the program. When you use something like assert to check conditions, it uses exit to stop the program early if the condition fails. So exit just says end the program, and when we return 0 from the main function, that's the same as sort of saying exit 0. 0 sort of means there were no errors, everything went fine. Exit 1, or exit anything other than 0, says I stopped the program but something went wrong. Exit 1 is just a sort of way of saying something went wrong but I won't tell you. But there are specific numbers we can pass into exit so that whatever started our program has some idea of why it stopped. Does that answer your question?
Is it only exit this function or the whole program?
This exits the whole program. The entire program just stops and dies and disappears. All good? Some other things I'd like to talk about with that program.